Hello. Ooh, hello. That's very loud. Let me move that further away. Um, Hi, welcome to Updates on Survey Strategy. The chair for this session is Federica Bianco and myself, Lynn Jones. I'm just going to give you a quick introduction and then hand it over to Fed to go through the bulk of all of the information we have. So, yes, that. Do we need to close the door over there? Yeah, I'll give this. All right, so as you should be familiar with, hopefully by now, we have a code of conduct for the meeting. You can go and find the code of conduct online, but just remember harassment and unprofessional conduct is not permitted and not tolerated. You can contact one of the people listed here to report any or get help with any incidents that you might feel you are uncomfortable with. Check people's name tags for their comfort level of contact. Wear a mask if you want. If you don't. If you do. It's all good. We have been reminded, asked to remind you that there have been positive cases of COVID at the meeting today, so wearing a mask might be a great idea. Also, remember the social battery pins. If people are wearing them and it is marked low, maybe they're just not in the mood to talk anymore. You can come back later or send a text. Okay, so for the people who are joining virtually, remember this is a fully hybrid meeting, so we have people in the room here and joining virtually. If you're a virtual participant, please be muted when you're not speaking. And in-person participants, let's try and talk into the microphones and also keep the I have heard that the Zoom microphones are pretty sensitive, so if you keep the chatter and crackliness or crinkliness down, that's great. We might need to wait a few more minutes because people are still settling in. If you have questions, please ask them on Slack, on the Slack channel. The channel for today would be day 3, yes, sorry, Wednesday, 10:30, Survey Cadence. And are you going to take questions with raised hands or? Yeah, we'll take questions. Right. Okay. So we will be taking questions as we go through. You can raise your hand on Zoom or in person, or you can type your question and we can ask it for you. All right. So just as a introduction to who is talking to you today, I am Lynn Jones. I'm the lead survey scheduling team scientist. And so this is actually a slide from one of our different presentations. So it does explain like how long we've been with the project and what's our like major specialty within the survey scheduling team. But the survey scheduling team is a project team. It consists of myself, Peter Yoakum, Eric Nielsen, and we have future members joining us over the next year or two of Hamna Ewan and Bryce Kalmbach. And then our stars for today are the Survey Cadence Optimization Committee. This is a community-based team who advise this project on the survey strategy. I'm maybe not going to list off all the members, but you are all very, very appreciated. And Fed is the chair of the Survey Cadence Optimization Committee, also known as the SCOC. The SCOC meets monthly, has annual workshops and dedicated event sessions. So usually these have been hybrid so far or online, virtual. The SCOC has liaisons in each science collaboration. So their job is to make sure that the SCOC is up to date with what the science collaborations are thinking about the survey strategy, and also to communicate information back to the science collaborations about what the SCOC sees as their next questions or priorities. The SCOC does have a monthly office hour, the last Monday of the month at 7 a.m. Pacific. And so you can drop in there with any questions that you might have once a month. And the monthly meeting minutes are available on Community, and they are posted in the survey strategy or survey scheduling group, but you can find them from this link here. I wanted to just give a brief introduction to the survey strategy. If you're in this session, most likely you have some familiarity with what our survey strategy is like, because we're providing updates on survey strategy. But if you still need more information about the basics of the survey strategy, we do actually have this very nice website, survey-strategy.lsst.io. And this is a new resource that we stood up this year. It contains background information on the survey strategy, information on the changes from one baseline to the next, some resources where you can get further information, such as how to use MAF or how to use the scheduler itself. And also it has updates from the SCOC. So this is a new site, and I'm hoping it becomes very useful. So now we're going to talk, I'm going to hand over to Fed so she can talk about the actual survey strategy optimization.
Thank you, Lynn. My name is Federica Bianco. I am Deputy Project Scientist in Rubin, and as part of my responsibilities in that role, as Lynn mentioned, I chair the Survey Cadence Optimization Committee. I'm a non-voting member on the committee, as is Lynn. So yes, Lynn is correct. You probably know what we're talking about, but in the spirit of inclusivity and make sure that everybody really does know what we're talking about, Interesting, there's a delay there. Let's talk about the survey strategy optimization process as it has been envisioned by Rubin Observatory. And actually, you'll hear more about this in the plenary on Friday, where the Survey Cadence Optimization Committee, but particularly the survey strategy team, are going to be honored for the milestones that they have reached leading up to operations. Circa 2014, Rubin Observatory has decided to open the process of optimizing the survey strategy to the community at large, as opposed to something more conventional that would be like only the people in power within the survey would decide what the survey strategy is. And we've done this with an iterative process, a little bit flying the plane as we were building it, so certainly there have been some hiccups. But the idea is we create realizations of the observing strategy as simulations that represent the pointing where the observatory is going to look in the sky and what are the conditions at that point for the whole 10 years of the survey. We share those simulations with the community. We have provided software that enables the community to link with those simulations. It's essentially a Python API that Lynn has produced in 2014, 2015, and is still being at the core of this exercise, where if you have a science case and you want to see how well would that science case come through in 10 years of survey, or maybe in the first year of the survey, you can plug your science case as Python code into the simulations and see how well it does. And you can compare the throughput, the scientific throughput across simulations. So that process started in 2014. First, the process was really extended to just members of the science collaboration. Then it got extended more broadly. We've gone through a number of versions of the simulations, which we call OPSIN. So right now we are at OPSIN 3. We'll release OPSIN 4 this year. And each one of those is a collection of simulations. Some of them are hundreds of simulations within. And in between producing the simulation, we release the simulation to the community and we ask for feedback, which we've asked in the form of collaborative papers that we wrote in 2015, 2017, led by Phil Marshall. This was called the COSEP. Later on, we had calls for white papers, calls for cadence notes. We put out forms, Google Forms, where you could answer pointed questions, and so on and so forth. So it's a really fairly complex iterative process. And the Survey Cadence Optimization Committee is the committee that receives the input from the community, the reports that you write, analyzes the metrics that you create against the simulations. And it was instituted in 2017, 2018, after the first white call paper. And it's a committee of community members with diverse expertise in all of the science areas that Rubin should cover, so that we can achieve an overall optimization. So Jelko likes to call this minimizing unhappiness. I want to be slightly more positive, and I believe that we are truly trying to maximize happiness across the entire science community. So part of this work, really the main workload has fallen on the community, and sort of like the side effect of having opened this process to the community is that the community had to do work, and that work is infrastructural and so often not recognized academically. So to alleviate the concern that people were asked to do work, but they couldn't really show that work as part of their academic portfolio, we have worked with the APJ, with the AAS journals and APJ supplements, and the editor Chris Linto to set up a Rubin Cadence focus issue, where now we have 21 papers being published and more are going to appear. This issue is still open. It will close when the SCOC publishes the current and final recommendation that we will deliver before the beginning of the survey itself. So early in 2025. And there's over 168 authors that have been publishing peer review work based on the work on the survey cadence. You have seen this slide from the plenary on Monday. The SCOC last official recommendation, I'll get back to some of this throughout the talk, was delivered at the end of 2022, and it was phase 2 recommendation. In that recommendation, we had collapsed a lot of the possibility of the survey strategy into concrete decisions and plans. We had defined the wide, fast, steep, low dust regions with the inclusion of the Virgo cluster. We have defined the 2 visits per night cadence that are roughly at 33 minutes time gap, and added a visit for a subset of the figures of the visits, added a 3rd visit roughly every 7th night to enhance short time scales cadence. We had committed to spending about 5 to 7% of the survey time on deep drilling fields. We'll get back to deep drilling fields later. And also we had recommended that a plan is developed for spending about 3% of the time on target of opportunity. We had committed to a rolling cadence. The concept of rolling cadence remains a little bit difficult to grasp, but we'll talk at length about that later. So for now, this is just a reminder of some of the decisions that had been made in phase 2 by the end of 2022. We also had identified a number of decisions that we weren't quite ready to make, and we listed them in the document that expressed these notes, which I think might be in the next slide, if I'm lucky. No. Never mind. We had listed the points that were still to be decided on in that document. We'll go over them today. We have answered all, if not most, if not all of them. I want to emphasize that this process, this iterative process that in the previous slide ended on 2023 with the most recent community contributions, is continuing on today. It will land as far as pre-survey work will officially end with phase 3 at the end of 2024. We're going to release the phase 3 document in September. But the work of the SCOC will continue throughout operation, and this is a really important point. The SCOC is a standing committee of the observatory that will continue to advise the director on survey strategy on an ongoing basis throughout the tenure of the survey operation. We have committed to providing annual updates to the survey strategy and review ongoing input from the community. Of course, when the survey starts, things will look different, and we do want to make sure that the community helps us make ascertain that the survey is really achieving the goal that we have set to achieve and enable any changes that might be necessary. Some of those changes may be due to technical aspects of the observatory that are different from what we expected. Some of those changes, I hope, will be due to scientific motivations. I hope that Rubin will truly be transformational, and therefore there will be a change of priorities in science that we might want to be able to respond to. So the process of the SCOC continues throughout operations. Let's take a look at the timeline, roughly where we are and where we're going shortly, and then in the more distant future. So the current baseline that we have released is version 3.4. You can find this baseline online. We can give you links and references for it, and you can play around with it with the maths to see how it works. In September 2024, we will release baseline 4 associated with the recommendation, the phase 3 recommendation. I want to make a point that is a little bit subtle. These baselines that we release with the recommendation are not, strictly speaking, what the observatory is going to do. They are an incarnation of our recommendation. Our recommendation goes to the director approves the recommendation, but what we release is the recommendation itself. So don't take it for granted that things will look exactly how we did, how we state in baseline 3.4 or in baseline 4. This is our recommendation to the director. Of course, we work very harmoniously with the director, and there is no reason so far to think that our recommendation will be rejected, but that's also always possible. In January 2025, we have a rotation of the committee members. About half of the committee rotates every 2 years. We're going to work on reviewing our recommendation throughout 2025 in the light of commissioning. Of course, what we recommend is on the basis of what we expect the system performance to be, but we will know in commissioning if there are significant aspects of the system performance that are different from what we expect, and we will see if those impact our recommendation and the recommendation needs to be changed. Then the survey will start, and in year 1, sometime probably near the half of year 1, we will ask the community to submit proposals for microsurveys. Microsurveys are surveys that take a small fraction of the time, a few % of the survey time. In phase 2 recommendation, we are committed to 2 microsurveys, a twilight microsurvey, and if possible, what was the other microsurvey? A Northern Stripe microsurvey if everything goes well, but we did not want to commit to microsurveys because those were urgent to be done in year 1 for a variety of reasons, which you can read about in phase 2 recommendation. But we had not committed to any microsurveys in the further future because we wanted to have more information about the efficiency of the system to understand how much time we have for microsurveys. So we'll issue a new call for microsurveys somewhere during year 1, hopefully early enough that we have enough time to maybe recommend year 2 microsurveys if possible, but after enough time that we have a better sense of the performance of the system and of how year 1 itself is going to go. All right. All right. So the SCOC process in a little bit more detail. What does the SCOC do? So, just stay here and I don't like. Okay, so the SCOC gets simulations produced by the survey strategy team that represent broadly speaking, recommendations from the community or changes to the system that require changes to the survey strategy. We'll see some examples of both. So we see them, the easiest way to show them to you is as maps of values across the sky. Here you see a map of 20th percentile internet gaps from version 3.4 of the simulation. There you see the maximum air mass on the footprint of the sky. But there's hundreds of these metrics. There's hundreds of things that we can visualize about each one of the simulations. We visualize them as metrics and we compare the math that I was talking about earlier. We compare how the math comes out from one simulation to another. So you will see a lot of plots like this in this talk. This is something that the SCOC would commonly be looking at. In particular, this selection of maths, these are all metrics that speak to different science. And I could even group them, like the top ones are roughly speaking solar system, then galaxy, then time domain, then cosmology, and the bottom ones are system metrics, things that we have to comply to for system performance. And the color represents how good the maths are doing in a comparative sense. And that's an important point. We're always just comparing the science throughput across different simulations. So in this case, we are using version 2.2 as our benchmark. And we're looking, are we improving or are we getting worse as we make changes? And if you see the color getting blue, it means we're improving. If the color gets red, it means you're getting worse. Largely, these maths got blue. There's always going to be a mix of blue and red. It's always going to be a trade-off. Something's always going to have to give. Other ways in which we visualize the maps, especially if it's a small group of maps, you may see plots like this. This is a radar plot. Closer to the center is worse. Outside is better. Every corner represents a math. Don't be fooled by the scaling. Always look at the center. What is the scaling? The center is 0.9. That means the worst maths here got 10% worse, not 100% worse. Okay? And the circle of reference is 1. So some metrics got 3% better in this particular case. And finally, you may see just line plots. I'm not going to explain them. This up is good, down is bad. And we usually look at the kind of ranges that we're looking at is if something changes by more than a couple percent, we start worrying. However, I want to emphasize that by the nature of the exercise, the maths as they're written by the community are hard to compare. So this is not a strictly mathematical exercise. We cannot write an algorithm that says, just give us a maximized blue. Because when we compare a 3% loss on kilonova throughput, that doesn't mean that it's a 3% loss on the science of kilonova. And when we compare a 10% gain on the detectability of NEO, that doesn't mean that that is necessarily a 10% gain in the science throughput. So the metrics, so to speak, are not in the same units, which means that the SCOC has to have a sophisticated and open mind when reviewing these metrics. Are there any questions so far? Okay. So this is the slide that I was looking for earlier. If you want to know what we recommended at the end of 2022, this is phase 2 recommendation. That's the incarnation of the phase 2 recommendation. It's baseline 3.0. This document is fairly long, maybe 50 pages at the top of my head, and very detailed. And there's a bunch of things that have been recommended and a bunch of things that have been highlighted as to be recommended. I want to give you a quick visual of how this process of observing strategy has really influenced the way in which Rubin will work. On the top left, you see version 1.0. This is circa 2014, the beginning of the process when we started including the community. That was the plan for the survey before the community started pitching in about how should we make things better. And then you see the evolution of the footprint. That's obviously the easiest thing that I can show you, but everything has changed. The cadence has changed. The filter balance has changed. So this is just to give you a sense of the incremental process and of the impact of the process. And another way to do that is to show you how much bluer we are on a heat map of maps, still the same maps that you were looking at earlier on nearly everything. We're doing much better. Version 2.0 is our benchmark because it's the first one that was vetted by as recommended by the SCOC, but this is where we started. We're doing much better on everything, on everything and globally than we were doing at the beginning. Okay. So I'm going to get into some more nitty-gritty stuff. These are the points that the SCOC had highlighted, needed decision that we weren't ready to deliver in phase 2 recommendation. We're going to go through each one of them, and there's multiple slides for each one of them. So this is going to be a long session. It's going to be a lot of me talking, but every one of them I'm going to stop and I'm going to open the discussion for all of them. But keep in mind that we do want to really get to the end. And in fact, the bottom ones are the ones that are not quite finalized, so perhaps the ones that require more discussion. So keep that in mind. The points that the SCOC had understood we needed to still deliver on where. Let me just briefly read them so you can get a sense of where we're going to and just pick in your head which ones you're really going to be interested in. The availability of filters on the filter wheel, that is whether we swap U and Y band or U and Z band or U and Z and Y band based on lunar phase. The filter balance that might need to be changed in response of on-sky throughput. We spent a fair amount of time here because as it turns out, we did change the filter balance. The target of opportunity strategy, the development of a strategy for target of opportunity observations, footprint filter balance and general optimization of the galactic science of the galactic plane and bulge footprint, whether we should do 2 × 15 seconds or 1 times 30-second exposures, at least from the scientific side of it. And then the uniformity of coads in the presence of rolling. You've already heard about it a couple of times during the meeting today, including when the desk presented its scientific progress and concerns, and internet cadence for deep drilling fields. And then we'll have some comments about early science, although that is a very complex area that involves not just the SCOC, but also a bunch of teams within the observatory. Okay. So let's start with the easy one, filter swaps. And during PSTN 05, right before we released the phase 2 recommendation, to which I will sometimes refer to as PSTN 055, that's the short link to the document. It had been suggested that swapping Y-band on the swapping U-band with Z-band and Y-band according to lunar cycles might be better than just swapping U-band with Z-band. The U-band with Z-band was what we had in the simulations that had been baseline before. So we wanted to see a lot more simulations before we committed to a decision on this. And we did that. This is the first thing that we did after phase 2 recommendation. And actually, the solution to this was very obvious. Really, the presence of Z-band on the filter helps a lot of science, particularly supernova cosmology. So the solution that is most, but swapping 3 filters instead of 2 filters affects the time gaps with which you can return to a field with the same filter, because obviously the filter is not on the filter wheel. So the solution was actually simply to swap U-band with Y-band instead of U-band with Z-band. So we have a 2 cycles rotation, depending on the moon, on the filter wheel that hosts 5 filters out of the 6 existing filters on the survey. We swap U and Y based on lunar condition, on lunar cycles. And you can see here in the radar plot, really the supernova metrics just blew out on this plot, indicating that the gains from these were really, really significant. And there's also some losses, particularly on the Trojans. I don't know where they are on this plot, but actually I want to remind you that these simulations don't always change one parameter at a time. In this simulation, we are also needed to put an update to the start date of the survey because of updates to the forecast. And that is actually what's impacting negatively the Trojans instead of the Y filter availability. Any questions on swapping the filters? Yes.
Sorry, just a clarification. What does it mean to swap U with Z and Y? Because as you said, there are five spots for 6 filters, and so
yeah,
it sounds like, yeah. If you can clarify.
Yeah. That. So U-band is never on in bright moon, but you can have U and Z or UM or Y. Yes, they're all 3 in the rotation. Yes. So we have a 2 filter rotation, and this recommendation has been implemented in several baselines already, starting with baseline 3.2. So the most recent simulations that you've seen all incorporate this recommendation. Okay. Filter balance in response to on-sky throughput. So the SCOC had a clear plan about what the good filter balance was under the conditions that the simulations were produced in. Filter balance is what fraction of observations are taken in every filter. Maybe I should have put the slide here about what the filter balance actually is, but generally speaking, we take more observations in R and I, with U-band gets the fewest observations, G-band is somewhere in between, I and Y, sorry, Z and Y, and get a little bit more than, a little bit closer to R and Y. So the concern here was that what if the throughput of the system is not what we think it is? This is a good filter balance for what we think the throughput is in each filter band. But if the throughput is different, we need to be open to revising this recommendation. And as it turns out, in the course of the last year, the throughput, in fact, has changed because the plan for coating the mirrors has been updated to coating the mirror not with aluminum, silver, aluminum. There's 3 mirrors in the system, which was sort of the straw person plan up until then, but rather to coat them all with silver. We refer to that as triple silver or AG times 3. So each mirror gets coated in silver. Why was this decision made? A number of reasons, but particularly relevant to the SCOC. This coating gets us closer to the survey requirements. So there's a document, the survey requirement document or SRD, that states what should be the throughput in each band based on the scientific goals of the survey. And this coating increasing significantly the throughput in red bands. It increases the throughput in G, R, I, Z, and Y. It gets all the bands but Z above design, to meet design requirement, but R to meet design requirement, and R gets close to design requirement, although it's still actually a little below the requirements of the survey, the design requirements of the survey, but with this change is above minimum requirement. And you see a visualization of that in the plot. This is a little bit complicated because there's a couple of things folded in the simulations that we use to measure this throughput. So your baseline here is old survey strategy, old throughput. This intermediate 1.8 here is old throughput, new old survey strategy. Yeah.
Yeah, sorry. So I kind of was not kind to Fed. This was, so 1.7 is the old simulations. 1.9 was the new simulations after we updated the throughputs and we used triple silver. 1.8 would have been an option if we had updated the throughputs, but not gone with triple silver if we'd gone with aluminum, silver, aluminum. There were no simulations actually made with 1.8. We only made simulations, we have the old simulations with 1.7 and we made new simulations with the 1.9 throughputs. The 1.8 is actually there for system engineering studies that we were doing in other parts of the project, not in survey strategy. The survey strategy got the choice that was made by the rest of the project that was informed by things from survey strategy, but that was a decision that was made and then we had to respond to it.
But so the punchline is that you want to look at these numbers. Positive numbers means increased throughput. So all the numbers are positive. All the bands get better, except for U band. And that's actually a problem that we're going to address in a second. Overall, the efficiency of the survey improves by 20% with this change. So what that means is that everything gets deeper. And when we look at the metrics that we have, all the, sometimes hundreds of metric or the short list of metric, they all get better. This is because most metric will respond well to increases in efficiency of the survey. That's a very easy thing to make your metrics just respond to. However, we heard from the community that there were concerns about the loss of throughput in U-band where we didn't have many metrics that were really addressing what is the influence of U-band throughput on our science. Particularly, we heard concerns about photometric redshift, photo Z. We heard concerns about Milky Way halo studies and Lyman break galaxies, all sensitive to how deep are your images in U-band. As I mentioned, we didn't actually have metrics for these. We kind of have a metric for photo Z. It's a bit cumbersome because it requires our friend Melissa Graham to actually run the metric when we give them the co-added depth of the survey. So Melissa stepped in and got involved in the process and helped us by running the metric against simulations that we made, where we change the exposure time in U-band, as well as the fraction of images that were taken in U-band, so the filter balance. We made this list of observations. We were increasing the throughput, the exposure time from 30 to 38 seconds. That's the number right here, to 45 seconds. We actually made a lot more, but we're not going to torture you with the 50 that we made. We're just going to show you a small subset. And then the fraction of observations that are taken in U-band. This is relative to what the number of observations that are taken in U-band on baseline 3. And reminder, U-band gets the smallest number of observations overall. So a 10% change in U-band is actually a small change on any of the other bands. So we get the 5 sigma depth. We ask Melissa to run the metrics. Melissa runs the metrics. And we are tracking photo Z, but we're hoping that the response that we get in photo Z is also reflecting what we would get if we had a metric on Milky Way halo and Lyman break galaxies and any other science in U-band. So this is low Z, that's high Z. This is the robust standard deviation of the photometric redshift. That's the robust bias of the photometric redshift. The dashed line is the requirement for the survey, the SRD requirement, which, as you see, is a straight line. It's not specified at which redshift it should be, but obviously the performance is different at different redshifts. What you want to look at is the black line, which was where we started from, version 3.2, before the change of throughput. And then all the color lines are simulations that have the new throughput, but different values of exposure in U-band and number of images in U-band. And there's this thing that is interesting that is happening, which is at low Z, we actually gain just because of the change in throughput. The change in throughput has improved photometric redshift up to redshift of about 1.5. However, it has impacted redshift of about 2 and became negative in redshift of about 2. So it's also not just like we need to make redshift what it was. We already have better redshift at lower redshifts, better photo Z at lower redshift. What is the right balance, right? Are we risking to lose the gains that we made at low redshift to mitigate the losses at high redshift? Which one is right? So lots of consultation with lots of people from the community. And then we decided that if we put back 8 seconds in each exposure and 10% of the images in U-band, we retain the gains in performance at low Z that we got from the throughput. We exceed the performance at within, it's within the errors, right? Obviously the errors are large here, but we exceed or at least meet the performance that we had before the change of throughput at high Z. So that's what we're going for. And our recommendation is going to be that we increase the U-band to 38 seconds per visit and add 10% of U-band observations. I want to make 2 points. We also, of course, look at all the impact that that would have on all the other metrics. This is the solution that we chose, and you compare it here with version 3.2, that's pre-change of throughput, and you can see that version 3.2 is almost uniformly redder, so there is an improvement from before the throughput on all the metrics that we're tracking here. I also need to make another note, which is that this is a change that requires data management input. Data management needs to assess the feasibility of extending the exposures to 38 seconds. So this is the recommendation of the SCOC. It will be incorporated in baseline 4.0. The realization of this recommendation is pending a feasibility study by data management. Questions on this?
Can you say again, in the comparison you're just describing, which line versus which line should we be comparing?
So 3.2 is before we changed the throughput.
That's the
So there were some small
line.
the black
line. We want to compare the black line and the red line.
And then the red line is the one that we chose.
Okay. Okay.
Yeah. And so green line is 30 seconds, 100% of the exposure. So that is the impact of the throughput change without any modifications of the survey strategy. So that if we didn't make this recommendation, we would land on the green line. Any other questions on this? Okay.
This is a very small change. What it does in practice is it sets the co-added depth in the U-band to basically what it was in 3.2. So we don't currently have a Lyman break galaxy metric in math. I do know DESC are working on one, but apparently that also shows like the same thing, like you would expect, because this high redshift is about where those Lyman break galaxies drop out. So I just wanted to add, there is a little bit extra evidence in favor of going to this direction, but it's not something that we have and that we can run.
Yes, I got a question about the sensitivity M5, which I guess is 5 sigma limiting magnitude across from U through Y. And so I guess I just wanted to point out that the the silver ×3 sensitivity.
This?
Yes, yeah.
Mhm.
So as you go from 1.7 to 1.9, the U-band sensitivity is qualitatively different from the sensitivities for the other bands, just because it's photon limited and
Mhm.
noise limited, right? The
Yeah,
rest
and there's some
are
other
background
differences.
limited.
That's right. There's some other differences that I have glided over. Like, for example, the exposures in U-band. We had decided long ago that that's going to be a single 30-second exposure because because it, as you said, it's qualitatively different.
So since the sensitivity for basically R through Y is background limited, the more time you put into it, it's not as effective.
That is correct.
So would you also consider shortening the exposures out there, because there's not, you shorten the exposures, there's not that much that you lose, as
So
opposed to
the
boosting up
adding,
the
so
exposure time for U-band.
that happens naturally because a lot of most of the metrics that we have, and also our intuition, is that most science is going to be more responsive to adding images than to just increasing the exposure time. So we are going to add 38 seconds and 10% of the images, as opposed to going to 45 seconds, right? And then the extra 8 seconds from the U-band image and the extra 10% gets spread even throughout the exposure time in the other bands. Shorter yet than what's in 38, yeah. Yep. Yes, please. Yeah. Mute. Hi, Mike.
Sorry, am I supposed to ask the question? It wasn't.
If you want to.
Sure, I asked, I don't quite understand what you mean that the data management has to assess whether there can be a change to 38 seconds. So could you explain what are the operational challenges then to making that change?
I see,
Maybe I
Robert.
misunderstood maybe
No,
what that means.
you're
Like,
right. That's what
why
I
can't
said.
we make a decision? Because it changed to 30 seconds, right? So why can't adding 8 seconds, why is 8 seconds a big difference from when it was switched to a full 30
Robert
second
will
exposure?
answer.
It's because the bias structure can be a function of the exposure time. So we have to special case every particular exposure. We're planning to do 30 seconds and probably without snaps in the main camera. So it's just adding work. And we'll be amazed if we don't do it. It's just a bookkeeping and are you answering? No, just stretching. I'd be amazed if DM didn't say it was okay, but it is an impact. It's not just that TX when the header changes and everything works. We have to be a bit more careful.
Thank you, Robert. There's another question from Mario in the back.
So this is a follow-up to Robert's comment. Does that mean that we'd have difficulty dynamically deciding, for example, that in a certain night we'd need to take a 45-second 45-second exposure for whatever reason?
It's partly a question for the camera team, so Aaron may want to answer it. In practice, we would do it if we had to, but there may be impacts.
So this is a detailed issue in how we do overscan and bias. It turns out that right now our thinking is that the optimal results will come from having calibration images taken with the same timing as the science images. So that means you would want to have pre-created calibration files at the timing that we use. It would not be difficult, I think, to have a few. If you had 15, 30, 38, 1, whatever it might be, but you just have to do it in advance. So then you would be able to dynamically pick timing should it be necessary. But, or you accept a small degradation in performance from not having them matched. So it's not a huge issue, I think. In the end, as Robert says, it does need some work. Actually, it needs some work for 30. So changing 38 is no issue. Sure, but it doesn't affect DM at all, whether it's 30 or 38.
All right. Anything else? Okay. All right, so we had the recommendation. We're going to move on to galactic plane and bulge. Oh, this one is exciting because we had a task force on this one. So the galactic planes, the way in which we survey the galactic plane and bulge, or maybe you want to refer to it as the non-low dust part of the wide, fast, deep footprint. It's kind of decoupled from the way in which we cover the wide, fast, deep footprint, up to a point, of course. But we can make choices that are slightly different and better for galaxy science on the footprint of the galactic plane and bulge than we make on the rest of the sky. So thus we optimize both galactic and extragalactic science at the same time. However, at the time of PSTN 055, so in December 2022, we weren't quite ready to settle on filter balance and footprint details for the galactic plane and bulge. In particular, there were some questions about, should we do some pencil beams or some small areas that get covered at higher density, kind of like think of them as deep drilling fields in the galactic plane, or should we shoot for a survey that is uniform? And actually, is Jay or Rachel, are they online in case I want to invite them if they want to chip in at any point to please speak up. Jay Strader, excellent. At any point if you want to jump in. Jay Strader and Rachel Street are co-chair of this task force, and there's a bunch of other members to whom we're extremely thankful, that have converged on recommendations on the galactic plane, which the SCOC broadly has reviewed and agreed with. So almost everything is settled. I'll show you some details that might need a little bit more work, but I consider this a finished job. So the first piece of recommendations, is going to be 4 parts in this recommendation, has to do with the footprint. There is an area of coverage that came out sort of like how we were covering different regions, and we ended up with an island right there. So the arrow for some reason is pointing in the wrong spot. It should be a little bit higher. We end up with an island, the green island there, that is at L45. Yes, the blob center L45. That wasn't really there for any scientific reason specifically, and it kind of breaks the survey uniformity. So the first recommendation is to move the observations that made that island into the bridge between bulge and plane. You see that here in this different projection than the projection that you saw before, of course. So those visits get shifted into this region, create a more cohesive galactic survey structure. The second recommendation is to not roll on the galactic plane. So hold on to this thought if you don't know what rolling means, because we'll cover what rolling means later. But essentially, just very briefly, it means you split the sky into region and you cover some region at higher density at some time, then at lower density at other time, and you alternate these regions of high and low coverage. Gives you a little bit more time domain coverage for the same overall depth in the 10-year survey. But in the galactic plane, for the extragalactic sky, there is a motivation for that. Is it to enhance time domain science broadly from, relatively slow transients like supernova 1A to fast transients. But for the galactic plane, there really didn't seem to be any advantage in doing it. So the recommendation is not to roll on the galactic plane. Most metrics, these are metrics specific to galactic science. These are OPSIN specifically made for these task force. These are metrics, and actually these are all the metrics. The ones that you see become red when we roll on the Milky Way are the ones particularly about microlensing. Microlensing was very sensitive to this and benefits from not rolling. None of the other metrics cared whether we were rolling or not on the galactic plane footprint, strictly on the galactic plane footprint. So the recommendation is not to roll on the plane or bulge. A third recommendation, now we have a new island, but that's a special island. This is particularly interesting to me because it speaks to survey coordination. Roman will have a deep field in the galactic plane. Microlensing science motivates that field coverage, and microlensing science really benefits from being done jointly with the ground-based LSST and the space-based Roman because it benefits from the parallax of the observations. So we looked at simulations that cover the same field as Roman at the same time as Roman parentheses, we don't know when Roman will cover that field, so we can't tell you when this will happen. But at some hypothetical points in time when Roman will cover that field, we want to shift some of the observations from within the galactic plane, so that does not impact extragalactic science at all, to cover that field more intensely. If you wish, you can think about it as a deep drilling field in the galactic plane, but we're not going to call that because we have a deep drilling field program with set deep drilling fields. These greatly enhance science in the galactic plane, a lot of science, and in particular, microlensing science, as shown by those metrics that have very mysterious names, but trust me, they relate to microlensing. Again, the scheduling of this cannot be finalized at this time, so we're going to need to keep an eye on coordination with Roman. And finally, we thought about whether we should change the filter balance in the galactic plane. Maybe the filter balance that we have for the YFAST for extragalactic science is not as beneficial for galactic science. But there really isn't a strong evidence that this is the case. There might be some hints that maybe it is, but not really any solid evidence. So at this time, the SCOC recommends that we start the survey on the galactic plane and bulge with the same filter balance as the rest of the LSST. We also recommend that the community continues to see if changing the filter balance might eventually be beneficial. And if they do, to let us know, because this is a parameter that can be changed throughout the survey. So please continue working and thinking about whether you can demonstrate that a changed filter balance on the galactic plane and bulge will be beneficial to your science. Build metrics that demonstrate that this is not a parameter that needs to be set for the 10 years of the survey, but it is a parameter, it is the way in which we're going to start the survey in 2025. There is a caveat to this, which is that we actually do expect that some regions of the sky, particularly the South Celestial Pole and the Milky Way clouds, will probably benefit from a bluer filter balance. So this is the part of this recommendation that is still pending. Those areas of the sky, I should put a map here, are actually outside of the bulge and galactic plane footprint. So to change the filter balance there, we need to be very careful that that doesn't impact efficiency or anything else on the extragalactic footprint. That's why we're being very cautious with that, and we're still going to work on it for the next couple of months, hoping to have a recommendation for what to do by September in phase 3, in the phase 3 report. And that concludes the galactic plane and bulge. Any questions? I secretly planted Michael here to ask me questions and break the silence.
So I'd like to understand a little bit more why rolling doesn't help in the galactic plane. You said that is the problem that there are no metrics that capture the short timescale variability, or there really is no interesting science at low latitudes? That just my intuition is puzzled by this. Yeah.
So none of the metrics, I'm going to ask the microlensing team right there to actually speak to this for a minute, but none of the metrics that we have that are not microlensing seem to be responsive to that increased coverage at like 48 hours, 24 hours. And the microlensing do suffer.
Hi. Yeah, so
Natasha, can you say who you are?
Hi, I'm Natasha. I'm a grad student in Berkeley, and I've been working on the microlensing metrics. Basically, for the microlensing metrics, we do see some improvement on like some of the shorter duration events, like 5 to 10 days. But the majority of the microlensing events happen between 20 and 30 days, and it's not fast enough to help the planets, which are even shorter than that, since shorter duration microlensing events correspond to less massive objects. And so, at least for microlensing, the idea was that the vast majority of events are not helped by rolling. I can't speak to other potential science cases, though.
Does that answer your question? Knut, will you help me to see if there is anything in the plane that you can think of that would benefit? Yeah.
Oh, sorry. No, I didn't see you. You can. Oh, okay. Okay. So maybe somebody else has something better to say. There are some metrics which were aimed at looking at what the timescales were for various things in the galactic plane. But the other thing to remember is that not all of the galactic plane gets as many visits as the wide fast deep. So we are talking about a relatively small area. And so one of those simulations was rolling everywhere in the galactic plane. One of them was rolling in one part of the galactic plane. There are just a lot of different timescales to consider. And I think the answer is that on the bulk, for things which needed monitoring at or measurements at timescales of more than 4 days, going to a rolling cadence cuts down the number of seasons that you're likely to see the thing, right? So rolling cadence enhances cadence at short timescales. If you need coverage every year at longer timescales, you do worse with rolling, right? Because in those years where you're at a low frequency, you get less visits. And so I think that it's just trying to balance across all of those science cases, and it's hard to have metrics that capture them all. And we don't have metrics that capture them all. And Rachel Street is trying really hard to get those in there, and she has something that sort of measures frequency, number of visits at different timescales, and this is the balance that they've come up with.
Can I chime in here?
Yes, please.
Yeah, hi, I'm
say
Jay
who you are.
Strader. Yeah, so I'm Jay Strader, right? I co-chaired the task force. I'm on the SCOC. It is not the case that there are literally no science cases that would benefit from rolling. It's that there are trade-offs. And if you go to rolling, then it absolutely kills discovery of galactic transients in the seasons in which the rolling is off. And when we looked at the metrics on net, that made the science worse. There are science cases that would benefit from rolling, but the committee that decided on net rolling was on net bad for science, even though there would be some advantages to it for some science cases.
Thank you. And this goes back to my initial point. It's always going to be a give and take. There's always going to be some science case that benefits from the opposite of the decision that we make. All right. Anything else on the galactic plane? Target of opportunity. So the recommendation of the SCOC in PSTN 055 was that the community comes together and gives us a plan for how to implement TO. The other piece of the recommendation that is not the pending question is we did recommend that there exists a TO program in Rubin that spends up to 3% of the Rubin time on targets of opportunity, particularly focusing on gravitational wave response as the most motivating case, but also consider perhaps broadening the program to other science cases, maybe in the future. They recommend that we set up a workshop in 2023 and that this workshop is accessible to the community at large. We did set it up. It was 2024, but you know, life is hard. And those are the chairs of the SCOC of this workshop. And I want to point out, first of all, Igor, because he's here, and he was. I can't speak enough about how much hard work he put in the workshop and the results of the workshop. But also because I want to point out that there's people with different backgrounds. We really wanted it to be not just gravitational wave people, but people that were thinking of science cases beyond gravitational waves, and also multi-messenger astronomy broadly and not limited to LIGO Virgo. So Igor, myself, Anna Frankovia, she's a neutrino expert, Tim Lister, solar system, Raffaella Margutti, transients and gravitational waves, and Grant Smith, lensing. We hosted the workshop at Berkeley with generous support from the Heisen-Simons Foundation. And we had, I was very proud about how this workshop went. First of all, we had a very significant participation. Over 100 people participated in a workshop. We did tell them very clearly, you're gonna have to sit down and do work, and hard work, every day that you come to the workshop. We also set it up to be completely hybrid. We even had staggered time zones of work, collaborative work between people that were in Europe, between people that were in Asia, and people local at Berkeley and in the US. Everything was hybrid, and that aspect actually worked very inclusively and very well. We had a very diverse audience, a number of grad students, a number of postdocs, and the science cases that arose were gravitational waves, neutrinos, solar system objects, particularly objects at risk of collision, and then a few people that were suggesting other science cases, particularly GRB, came up. with a few participants. Altogether, the committee, the workshop produced a document which is accessible here. You can find it at this short link. It will also be posted on the archive very shortly, with a bunch of authors, everybody that was at the workshop, and then some. And the recommendation, I just broke it down very trivially here by number of hours that they suggested spending on each science case. If you look at this number of hours, this actually totals up to just over 3% of the survey, of the 10-year survey time. With an interesting caveat, obviously, which is that the bulk of the time is spent on gravitational waves, but that is spent in a concentrated time slot during the LIGO Virgo runs, 05, which is now expected in 2027. 2027. So, and you can also see that the gravitational wave case got sort of subdivided into some different cases of interest because they would require different observing strategies. And for each of these science cases, we got recommendations on what are the targets to actually respond to, what are the parameters that we should look at to see whether we want to respond to the target, what is the strategy as a function of those parameters of each target, and those strategies can vary quite significantly. So I'm going to show you some footprint maps of our simulations of that implementation. I want to also say that we did simulations of the recommendation, simulations of downscoped versions of the recommendation, simulations of upscoped versions of the recommendation, primarily bringing up and down the number of targets, or maybe removing some elements, some targets altogether. This is how the footprint of TOs for gravitational wave looks after 10 years, but really that just means during O5 under best guesses for the event rate that we will have in O5, which I want to acknowledge, have a large scatter. This is the footprint for a specific subcase that requires a very different survey strategy. That's a lens binary neutron star, where the survey strategy will be to go much deeper than for a regular gravitational wave event. But this is exceedingly rare. So while it takes more time, it's an exceedingly rare event. So we only simulated a couple. We have neutrinos. These are single field events typically. And we have solar system objects. Altogether, we think that this is a great opportunity for Rubin to do maybe transformative science. This is not what the observatory was designed to do at the beginning, but there's definitely capabilities to turn Rubin into a target of opportunity responding system. So the recommendation of the SCOC is that the TO program is implemented as recommended in the workshop by the community at large. And here you see the version 3.4 of the simulation and what happens if we add TOs, and you see that really the impact on any other science is minor. And also consider that most likely these simulations overestimate the number of triggers that will actually follow. So we think that there is nearly no loss on any science case and a significant advantage in discovery potential. We also recommend that the neutrino and solar system program start right away. This will also give us the chance to flex our muscle and test the system ahead of O5, which will start in 2027. And we also want to recommend that there is another workshop closer to O5 to make sure that when we know better the properties of the system, of the LIGO Virgo system, we can maybe refine a bit the strategy that was proposed in Rubin TO 2024. Finally, there are some details that I wanna, in the interest of time, I'm just not gonna dwell on, but for the people that are interested in TOs, we do have a plan of implementing entirely algorithmic solutions for the TO program. So there should be an algorithm that takes you end to end from this is a trigger from Shima or whatever distribution system you get. These are the characteristics. Therefore, you should pick up the trigger and start the observation or not, but also to have a human in the loop that has power to override the decision of the algorithm and maybe embrace a TO that was rejected or not follow a TO that was algorithmically accepted, and an advisory committee backing up the person that makes the decision, made up of community members, of course. And we haven't quite talked about how people get on this committee, but there will be a standard nomination and selection process with eye on diversity and inclusivity and making sure that all the expertise are needed are on the committee. That's the end of the TO. So I'm going to ask you if you have any questions. Hi, Azali.
Hi, so I'm clearly really excited about the TO program. I'm wondering if you kind of mapped out all of the science cases you can think of, but my hope is that Rubin discovers new things that we haven't thought of. What is the plan for kind of how to respond to something, let's say in real time, that hasn't been approved as a science case or something like that?
So that's part of the reason. Well, that's part of the reason for two things: for having a SCOC that can advise the program, has committed to advise the director has committed to advise the director annually, but can also jump in and advise the director in between if there are some urgent changes. That's also the reason why we have a committee that advises the TO program implementation in real time. So certainly those cases can be embraced. There is this ongoing discussion about like, how do we embrace changes in survey strategy during operation? That is too long to have here, but just to say this is something that we're thinking of, and certainly, yeah, I certainly expect we would respond to exciting things. That's our job.
Yeah, I agree with that sentiment. The devil's in the details, but if you put up that list, that marvelous laundry list you had of in the previous sliders or two back, you look through this list on the left there. Before one more, no, keep going forward. The list, you had a laundry list. You had a list of science drivers on the y-axis. So there you go, that one. So you look at all those marvelous things on the left, and of course you don't see what you were just advocating, mainly something totally new and surprising and unexpected. And so what I mean, devil in details, for example, if you're spending a huge amount of time, for example, on following up gravitational wave detections, which is a great idea, what filter do you choose first? And there's a natural bias. We all have these, natural bias to what we know and what we've been studying. So the optimal filter for following up kilonova may not be the optimal filter sequence to follow up something weird.
And Tony was at our workshop, and he's one of the people that created the recommendation. So certainly we want to be responsive, and for different things that we haven't considered, the strategy will change, but also for the things that we have considered, right? We may discover new things that will suggest that we need to update the way in which we design the observations. We do intend these to be a flexible program throughout. All right. In the interest of time, I'm going to go to something that I expect, something that I think is going to be easy. There's the observations you probably have heard over time. Rubin will take observations every 30 seconds, but it's actually 2 15 seconds exposures, co-added and combined into a single 30-second visit. But it's possible that that the system can take a single visit. And so the question that we asked in PSTN 055 was, well, we're not actually quite ready to say whether it should be 2 15 seconds or 1 30 seconds, because we don't know if it's technically feasible to do 1 30 seconds. However, we were encouraged at the meeting, at the PCW meeting last year, by the community to have a scientifically based recommendation that is pending the feasibility study that will happen and will necessarily happen in commissioning on SCI. So not to wait until we know, but to just decide whether scientifically we want to embrace the 1 × 30 seconds or the 2 × 15. Going from 2 × 15 to 1 × 30 seconds brings an extremely large comparative efficiency increase, 7 to 9%. That benefits all science cases broadly. Now, there might be some science cases that will benefit from the 2 15 seconds, of course. Saturations limit will change, but that's limited to a very small number of sources that will be impacted because the change is small. Some science cases might benefit from you working with a single exposure, the 15-second exposures, but those are not actually released by the project. So all of that science will require custom pipelines. We just don't see any scientific opportunity that is compelling enough to compete with the 7 to 9% efficiency gain. So the position of the SCOC is that we recommend that if it's feasible, if it's demonstrated to be feasible in commissioning, we do move to 1 times 30 seconds exposures. Michael, and then Wes. We are running a little bit late.
Okay.
We do have to discuss rolling and deep drilling fields.
Okay, very briefly. Doing at least one coverage of the sky at 15 seconds might be useful for sort of increasing the dynamic range at the bright end for the static sky, getting it on the same photometric system.
Right. So the SCOC has even, some members of the SCOC have even suggested that if there is a scientific benefit to 2 times 15 seconds, maybe that could be a microsurvey. Now, there's some technical details though, because maintaining both, the system for doing both is difficult. So, or at least is it not trivial.
Hey, this is Wes Fraser. Just curious, what technical limitations might there be to taking a 30-second exposure? That seems
so
pretty straightforward.
the 2 times 15 seconds, and if Robert wants to jump in, feel free, but the 2 times 15 seconds exposure were originally designed for cosmic ray rejection. It doesn't seem like they're needed for cosmic ray rejection. We do have to demonstrate on Sky that, in fact, they're not needed for cosmic ray rejection. And there will be like a number of contaminated sources, perhaps, that we need to evaluate, maybe evaluate comparatively with the 7% gain. All right, so this is gonna be fun. Rolling cadence and uniformity, you've heard about this already a little bit. If you were at the SAC meeting on Monday and at this morning science collaborations, it might have trickled into some other sessions that I wasn't at. So the SCOC had recommended in PSTN 055 that A, Rubin rolls. So I'll tell you what rolling means in a second. B, that Rubin rolls at a strength of 0.9. C, that Rubin rolls at a strength of 0.9 on 2 sky areas. However, members of the extragalactic science community at large, and DESC in particular, had highlighted that this rolling increases non-uniformity in data releases intermediate between year 1 and year 10, and might compromise, to some extent, cosmological analysis at key data releases. So the recommendation of the task force, I know that perhaps a lot of the things that I said were unclear. I'll clear them up in a second. The recommendation of the task force is that software solutions are looked at to see if in software this problem can be resolved. So if the data releases can be delivered to be more uniform by software, by processing the images different. Nonetheless, the SCOC has also opened the door to see if we can alleviate the problem in survey strategy, and we created a task force for 2 purposes. One was to quantify what is the necessary uniformity. We didn't have a quantification of how uniform the data releases had to be to enable science. And also to explore alternative solutions to rolling that might lead to more uniform data releases within the constraints set in PSTN 055. So what is rolling? I said we alternate areas of sky. We cover them 1 year more intensely, the second year less intensely, switching which area of sky. The rolling is set up in 2 areas, 2 zones, but there are actually 4 stripes across the sky. So 2 of these stripes, alternating 2, get covered intensely in 1 year and less intensely, and the other ones get covered more intensely in alternating years, okay? That's how the rolling is planned. The parameter 0.9 means that the scheduler is gonna ask for 90% of the observations to be in the season that gets covered intensely, but actually that's not gonna happen because there's other requirements, like we need to build templates, we need to get at least this many images in each filter, blah, blah, blah. So when you ask 0.9, it turns out to be that 75–80% of the images are in the high intensity region and the rest in the low intensity region. And you alternate them every year. We're not gonna roll in year 1. We need a uniform survey to set the stage and start all the science. That means we also cannot roll in year 10 because we need to alternate. So we need 2-year cycles. Each rolling cycle is 2 years. Otherwise you end up with the high intensity region, but never catch up on the low intensity region. So we have 8 years during which we can roll, and therefore 4 potential rolling cycles. Fun fact, we actually hadn't quite paid attention to this parameter until this year. So there's been simulations with 3 rolling cycles and simulations with 4 rolling cycles, but we weren't really aware of these changes in the simulations deliberately. We didn't know that was a tweakable parameter. This is important because this comes up in the story of what we're considering now to implement as rolling. Version 3.0, that was the baseline that came with PSTN 055, actually had 3 rolling cycles. All the baselines after had 4 rolling cycles. Until our task force, which I'm going to pop up again, just to thank Rachel Mandelbaum, who worked extremely hard on leading this task force for, I think, in excess of a year. I think we actually announced that we were going to have this task force in maybe May 2023, and we've discussed it at the last PCW. We've discussed it at all the workshops that were at the SCOC workshops, and also Rachel has talked about it in many venues throughout. Okay. And many other members, or in particular, Matthew Baker, who also was instrumental in developing concepts for different rolling strategies. So the rolling leads to ununiform data releases. This is if we just roll like we in 4 cycles, as I described earlier. This is how data release in year 4 looks like. The problem is that year 4 is a key data release for cosmology. It's a year when the Dark Energy Science Collaboration plans on releasing cosmological analysis, and you're limited to the lowest depth area of the sky. So this really compromises the cosmological analysis in year 4. There are 2 key data releases, year 4 and year 7, that the desk is focusing on to deliver cosmology. So in the task force, they propose an alternative way of rolling, which we call uniform rolling. Effectively, what you do is you start rolling in year 2, but then you pause rolling before year 4 to cover the sky uniformly and catch up on the low coverage areas. So you get a more uniform release. You do the same in year 7 and then in year 10. And so you see the intermediate data releases, year 4, year 7, the uniformity under rolling, under uniform rolling, under no rolling. This is not on the table. The bottom one is for comparative purposes only. It's not on the table. PSTN 255, we shall roll. Okay. All right. I guess I animated this slide. So uniform rolling, already described it. To enable uniform rolling, you cap the cycles to 3 cycles. You need the pauses in between. They end up being, and then they end up making it so that you only have 6 years during which you can roll. Uniformity is desirable for extragalactic science at large and cosmology in particular. And we have a note by the cosmology, by the desk, by the Dark Energy Science Collaboration that stated uniformity cadence advocated for the uniform year 1, year 4, year 7, and year 10 for static science with minimal effects on transients. So from the cosmology point of view, this rolling strategy provides static science benefits and minimal loss to time domain cosmological probes. Going a little fast through the slides, you can find the report at this link. And if you don't want to click on the slides, LSST, ls.st/SCOC SC reports takes you to all the reports that we ever received from the science collaboration. So the uniform rolling proposed strategy provides improvements of 30% on survey uniformity at year releases 4 and 7, over rolling in 4 cycles, the same way as I described earlier. The rolling cadence, so rolling in 4 cycles would increase cosmological time domain probes efficient throughput by 33% compared to no rolling. Rolling uniform would improve time domain cosmological probes by 29%. So there is a loss, but it's small. So there is a net significant benefit for static probes. There is a small loss for cosmological time domain probes. However, that's not the end of the story. The rolling primarily impacts the timescales of 24 to 48 hours. the timescales that are really relevant for supernova cosmology are slightly longer. There's very interesting timescales that are shorter within the night, but we do have triplet images for those. So even if you don't roll, you don't really lose coverage in those timescales. The timescales that are sensitive to how many cycles of rolling we have are 24 to 48 hours. And you basically lose 7% of coverage in those timescales for every cycle that you drop. So, okay, so the metrics that we see are impacted by this, of the collection of metrics that we usually look at, are primarily the kilonova metric. But really, there's a bit of a trick here, which is that the kilonova metric is kind of a placeholder for us for anything that happens on timescales of a few days, a few hours to a few days. So we've been using it as the one science metric that we have for generally fast transients and maybe even unknowns and unusual objects. So the questions that we have, and we're going to ask this question to the time domain community, is what does it actually mean to lose 7% coverage in those timescales in terms of scientific loss? Is it a 7% in scientific loss, or is it a different number in scientific loss? I have a few more slides on this that explain why we lose that 7%, but let me skip in the interest of time and take you to what our thinking currently is, which as a spoiler alert is at the bottom, but I'm going to take you through it. So the SCOC study survey strategy solution to the uniformity challenge that may compromise cosmology to mitigate the problem that otherwise would need to be solved at the software level. The SCOC is grateful for the work of the task force in developing both metrics to evaluate uniformity and new approaches to rolling. The SCOC believes that rolling uniform, the rolling strategy that I presented, is a very promising solution and a good compromise potentially, certainly a good compromise for cosmology. The new rolling proposal complies with phase 2 recommendation, because phase 2 recommendation had released a 3-cycle baseline, and it's still at 0.9 strength, and it's still in 2 regions. However, there is this new parameter that we have not explored, and more importantly, that the community has not explored, the number of rolling cycles. So the impact of the number of cycles, as well as the loss of coverage at 24 to 48 hours, is not fully vetted scientifically. So we want to give the community the opportunity to think about it and ponder it and play with the simulations and understand if there are any implications of this that we have not fully understood. And this is the key. We don't have to decide on rolling now, because like I said at the beginning, we're not going to roll in year 1. So we don't have to tell you how we're going to roll until the beginning of year 2. So we're going to postpone the decision of how rolling is implemented until then, and give the community the opportunity and the simulations to advocate for rolling, maybe explore different rolling strategies yet, and also vet the robustness of this new proposal to different outcomes in year 1. Because one additional caveat is that we can't actually start rolling until we have a good calibration over the entire sky. And this rolling uniform requires rolling very early in year 2. So there is a question of what happens if year 1 doesn't go that well, and we cannot start at the beginning of year 2. Those are questions that we haven't had the time to ponder. This is a new strategy. And now I open the floor for questions and comments. I certainly expected more questions and comments.
Oh,
We only have 5 minutes and we do want to discuss DDFs. So if there are no comments, I can actually move to DDFs. This should be quick, but I want to also acknowledge the work of the DDF task force. We still have to decide on the intranight cadence for deep drilling fields. We haven't decided yet. This is a pending recommendation. I don't have an answer for you yet. But we have a task force that is working on this and that has decided on other aspects of the deep drilling fields, led heroically by Saurabh Jha, who did a massive amount of work on DDF in the last several months. I don't know if Saurabh is here. This is the general scheme for DDFs. There's no changes. There's 5 DDFs. They take about 7% of the survey time. Cosmos receives about 40,000 visits. all the other ones about 20,000, and the Euclid Deep Field South is split into two with 10,000 each. We have some recommendations, no recommendation for the internet cadence yet, we're still working on it, but we're gonna recommend that the deep drilling field observation should be sequences similar to the wide fast deep, so with the same exposure time. So 30 seconds if we go to 30 seconds, 2 times 15 if we stay with 2 times 15. This makes it easier to process the images and stacks can be created. It also enables alert generation in the same way in which we generate alerts on the wide fast deep. The SCOC recommends that the translational dithering for DDX is minimal. And we think that we moved from what it was planned to be, 0.7 degrees to 0.2 degrees. We worked with the Rubin team to see that that was possible, but we also encourage exploration of whether it could be further reduced. And this has been vetted by both people that work on deep drilling fields time domain science, as well as static science and low surface brightness science. And we recommend that the baseline strategy should accommodate possibly variation on how we observe the fields. Not all the fields have to be observed exactly the same way. And we want to be responsive and dynamic in how we allocate filters and also which time during the survey the fields get observed. There might be prioritizations that will be scientifically beneficial. Finally, we're going to urge data management here. Hello, Yusra. To think about alert production, and Eric is here, to think about delivering alerts for intra-night transients on the deep drilling fields. That doesn't have to be done within the night. We can get the alerts in real time, like it's done for the wide fast deep. What we would like them to seriously create a path to delivering alerts with templates built from within the night, as opposed to with the standard templates. There are other timescales that people might be interested in, maybe weekly templates, but we really want to prioritize like intranights, templates, and alerts based on that. So we're gonna ask that data management considers this. We already had multiple conversations with the alert production team. We think that this is possible. We just want to know that a path is being developed to build the required infrastructure. And that's all I have for the deep drilling fields. Questions on this? Questions on the rolling cadence? Yes.
You focus on the science cases. I wonder you didn't present any issue about the quality of the data. For example, like air mass, average air mass for different cadence or other qualities, so which might be important even year one.
Sure. There's literally hundreds of things that we track. And we can point you to, maybe we'll put it on the Slack. We can point you to places where you can see all of these variables being tracked, including the air mass. Actually, Riley Clark had a plot of the air mass for a science case that is relevant to that, with the distribution of air masses throughout the survey. So all of that information is available. This slide deck would be 5 million pages if I put them all here, but we can put on Slack where you can find any of the parameters that you're interested in. And if you don't find the one that you're interested in already pre-compiled and measured, just reach out to us and we can talk to you about whether it is possible to measure it, how to build the math to measure it. Any final results which are important? I think all the 6 decisions that we made are important. I don't think I can choose any of my children. Mike, do you want to unmute?
Yeah, I wanted to ask a question about rolling cadence and this proposed change for uniformity, because I'm really worried about it, because we're talking about simulations and making a decision for year 2. But we're actually going to have the entire system working, right, in year 1. But part of the problem is that the community is not going to get the data set or the data release, which to me, from my understanding of the issue that Desk is talking about, really matters about the systematics and how you can process the data. And they're not going to get that until the data release 1, right? The six months data release. for 6 months. And that's only going to drop at the start of year 2. So how are we going to make a decision when we actually have the data set that could tell us to make a decision when we have to, the survey's got to be running. And so is the plan to make a decision off of the simulations when we haven't necessarily calibrated them or adjusted the, right, when we have the data, right, to look at and see whether desk sees the things that they're predicting to be as bad, or, you know, maybe things are better or worse, right, in the actual data itself. And so is there, I'm just trying to understand that difference of why not make a decision after year 2 and just leave year 2 as is. How much difference is that going to make in overall uniformity if you fix it afterwards?
So in order to implement the rolling uniform, we need to start rolling at the early on in year 2. Otherwise, we just have the cycles. So to implement the solution that right now the desk and has favored, and extragalactic and galaxies as well, we need to start rolling it at the beginning of year 2. There's just, you know, we need the space for the 3 cycles with the pauses in between. I want to say that this is the reason why we want people to build the metrics, right? And build metrics that we can run independently, so we can run them on simulated or real images. But what you're saying, not to minimize what you're saying, because it's also true that, you know, like it's not the same if we run the metrics as if the experts in the science community that really want to develop the science run the metrics. So it is a concern. There's people in the desk who are also in the various commissioning and data management teams. So certainly that provides a link. But we can't just not roll in year 2 or roll. We're actually kind of trying to look to see if, like, can we start rolling? Does rolling start the same way in the 2 scenarios? And when do they really diverge? But it looks at the moment that the solutions that we have diverge early on in year 2.
So in the interest of discovering the unexpected, in particular with multi-messenger facilities, one or several of these deep drilling fields is a perfect opportunity for co-observing, where you have several different types of facilities observing the same place in the sky at the same time.
Certainly, and there's a lot of groups that are working on coordination with Roman, with Euclid. Perhaps you're right, I didn't spell out that part of our recommendation would be coordination. It was in PSTN 055, but we should iterate on that. You know, from the point of view of the SCOC, we make recommendations, so we can recommend that coordination is enabled, supported, and facilitated. And then we can ask the community help us highlight the scientific advantages of it, which are obviously many, and point taken. Leanne, and then is the session over?
Hello, can you hear me?
Hello, Leanne. Yes.
Hi, great. Could you go back to the previous slide, Fed?
Say it again.
Could you go back to the previous slide? Deep drilling fields. Yeah, it's about the nightly. Yes, it's about the nightly coads. You're recommending that we consider producing alerts from nightly coads.
Yeah.
We will consider this and study this in DM. We have there's no commitment to do this yet, but we know it's a topic. We've heard about it before, and we're going to consider it. Just a quick question though. It would be very difficult, I think, to do this in year 1, given that we're not going to have alert templates. Alert production is going to be ramping up slowly. So if we did do this, I think it would be something to do from year 2. Is that a concern for anyone?
No, I think the SCOC understands that this is not something that we expect to be delivered in year 1. What we would like to have perhaps the spirit of the recommendation is that we have had many conversations that say this should be possible. And we're definitely thinking about it very seriously. And we would like something a little bit more concrete, like perhaps a document that states that this will be enabled and a path to see it enabled.
Okay, that sounds good.
I guess we're trying to gently push the process.
Yeah, I mean, we'll come back. We'll do a study on this, and we'll come back to you with more questions, I'm sure. It's really going to be a case of, you know, we're adding something else into the system. it takes resources to do it. It's as similar as the question for, you know, the 38 seconds in the U-band. It's not that we want or even plan to say no. Nobody wants to say no to this. It's just that there's always a non-zero amount of work in adapting the system in order to do this. And it's a case of understanding what the trade-offs would be, which is more important. When do you need something? How would we, you know, how would we integrate it? Where do we get the resources?
If I had to put a time, well, there's two timelines here. There's when do we need it for the DDS? As soon as possible. Certainly we don't expect it in year one. This will be something that is important for gravitational wave TOs. So certainly we expect to see it by then, by 2027. But you know, the sooner the better, with understanding that this is additional work and change requests and all that. Thank you, Leanne.
Okay. All right. Thank you.
There's Mario in the back, but I do want to let people know, and Francisco, they wanted to let people know that if they want to leave, they're free to leave, even if we're still going to keep talking. Mario.
So you mentioned in the last slide that year one is going to be slightly different also because we don't have templates. So
Yes.
to what degree do these cadence evaluations and the metrics take that into account? Because that's potentially a 10% effect for time domain science.
Sorry, I didn't hear everything, but I think I got the spirit of the question. And I think I even have a slide on it. So we really haven't had enough time or maybe courage to explore, you know, how sensitive is what we are recommending to outcomes in year one. But we are doing it. We're starting to do that now. Now that we have more reasonable projection for, you know, reasonable amount of engineering time that may be required in year one. What is a good case scenario? What is a expected amount? What is a bad case scenario? So we need to explore that, and we need to. This is going to be the focus of, you know, the rest of the year and early next year. Did I answer the question that I didn't hear, or didn't I? I didn't hear it. So chances are I did.
I was just wondering, do we have a plan for template building in year one?
Oh, okay. Easier question. Good. So I answered the hard question that I didn't have to answer. So it's a multi-team sort of that need to come together to make this decision. I think the position of the SCOC is that the priority in year one has to be to get a good year one set of calibration images over full sky coverage. And we did receive some input from the community about prioritization of different filters, so we will communicate that. But I think the priority of building a uniform set of images has to be the main goal of year one. Having said that, in the process getting to that, we will collect enough images to build templates. So as you know, we have a plan of building templates incrementally. As soon as a region of the sky has enough images to build a template, which is a lesser quality template, then it will be in year two. So we think 3 images are sufficient. That template will be built, and the alerts will be released from there on. We did have some input on prioritizing filters over other filters. I don't know that it's enough input for us to tip the scale as of yet and make a recommendation on how to change the plan. But, you know, if you have input, we will take that input. Francisco.
Thank you. This is amazing. It's a lot of work. Thank you. We appreciate it. So I have a question about the some lessons learned from the elastic challenge, classification challenge from the brokers, where the brokers team were trying to classify simulated data, and there were many changes happening until the last week of the challenge, and this led to burning out of the teams that participated in the challenge. So they didn't want to continue participating. So I think one lesson is perhaps it's better to have more clarity in advance, but keep doing changes until the last minute.
What were the changes at the last minute? Sorry, I didn't follow that.
Many details we can talk later, but in the simulations.
In
so
the
you have to train. You have to keep.
So
training. Yeah.
So to some extent, we are addressing that. We used to release very broadly all the simulations that we were making. We're trying to be a little bit more clear about what are simulations that are really just made for the SCOC to like stress a parameter and see where it goes in which direction and how fast, and simulations that are, so to speak, under consideration. So that reduces, so if you pay attention to how we describe the simulation, from the last set on community, there will be, you know, this simulation does this, and then there's this whole list of simulations that are.
No, I mean, yes,
But
just as a general comment, that is because the next stage I think is going to be AI, like training models, and
yeah,
once this is established, we will be simulating data and training machine learning models and so on. And
but I mean, you're right, because part of the issue is that we need simulations to be stable to develop AI based on it, but we also want the system to be dynamic, as we heard from many people. We need to be responding to changes. So there is a sweet spot. You're right. I think we're decimated. So I want to thank everybody who stayed until the end.